Hello and welcome to Core 4 Revision with Mr. Quinn. Today we will be working through the June 2010 MEI Core 4 paper. I will be giving hints followed by work solutions. I would encourage you though to attempt the questions after listening to the hints, and only after this should you refer to the work solutions. Question 5. Looking at partial fractions. The word hence giving a hint that we're probably going to use the answer to part 1 in part 2. Here you might notice we have x's and y's on the side of the differential equation. You're going to have to use some separation of variables. Hit pause and give it a go. Work solutions. Using the method of partial fractions, we can see that the left hand side is equivalent to the right hand side. We do though, however, need to find a and b. To do this, we set 3 as being equal to a times y plus 1 plus b times y minus 2. If we let y equals minus 1, this gives 3 being equal to, if y is minus 1, this becomes 0. 0 times a gives 0, meaning we're left with minus 1 minus 2 giving minus 3b. Therefore b is equal to minus 1. If we let y equal to 2, this again gives 3 being equal to, but this time the 2 minus 2 is 0, 0 times b is 0, so we're only left with a value for a. 2 plus 1 is 3, so we end up with 3a. This gives a being equal to 1, giving us an answer of 1 over y minus 2 minus 1 over y plus 1. Moving on to part 2 now. Again remembering our hence. If you look at the differential equation, you again see we have y's on the right hand side when we're looking for dy dx. We need to use separation of variables. To do this, we can divide through by y minus 2, y plus 1. This gives, and as you can see, the left hand side resembles the left hand side up here from part 1, which then we simplified using partial fractions to give this. This is much more easy to integrate. As you can see, integrating the left hand side gives us the natural log of y minus 2 subtract the natural log of y plus 1. On the right hand side we have a third x cubed plus our constant of integration. Using our rules of logs, we can combine the two natural logs to get the natural log of y minus 2 divided by y plus 1. And the right hand side remains the same. If at this point we use base e, you may see, with e being the inverse of the natural log, this gives us, on the left hand side, y minus 2 over y plus 1 being equal to e to the power of a third x cubed, this time using rules of indices, times e to the power of c. Here, e to the power of c, well, e is just a number, c is a constant, so a number to a power of a constant is just another constant. So we can now rewrite e to the power of c is equal to a constant a. This gives us y minus 2 over y plus 1 is equal to a times e to the power of a third x cubed, as required.